Hi Bengals, this is Mrs. Timmons. Today we are going to be looking at weather fronts. Specifically, we're going to talk about the 4 types of fronts, how they impact local weather, and then how they interact with high pressure systems to create different types of weather patterns like storms, dry weather, things like that. So I want to point out a couple things. This is kind of a traditional weather map. Whenever you watch the news, if you do watch the news, they'll use a map like this to explain what's happening to the weather in Houston or around Houston. And I want to point out a couple things. Notice areas where it has high pressure, there's not a lot of cloud cover or storms. All these green and then the white and the orange, all of these involve some sort of precipitation. The green, the yellow, the orange, all of that is rain. The blue up here with the white, that's all snow or anything that's frozen precipitation. But those are all primarily in areas that have low pressure systems nearby. High pressure systems, they don't have it. Now, these 2 low pressure systems sitting over here in the middle of the United States, please understand that low pressure doesn't mean it's always going to have storms, but it can have possible storms. So we've talked about how high pressure days are going to be clear and sunny. Low pressure days can be stormy, cloudy, that sort of thing. So today we're going to be talking about what these fronts, these lines with the triangles, these lines with the circles, what those mean and how they work together with those pressure systems to form various weather patterns. So let's first talk about what a weather pattern or what a weather front is. A weather front is defined as a boundary between air masses of different temperatures. It causes a temporary change in weather. So when we say that there's a cold front, all that means is that the front of air that is coming through is colder than the existing air in that area. So a cold front in the middle of July could be 80 degrees, and that would be considered a cold front. Likewise, a warm front in the middle of January could be 40 degrees when it's actually 30 outside. All it means is that it's colder or warmer than the air masses it's traveling into. So let's get into the first of the 4 types. We're going to talk about the cold front first. The cold front is described as a fast-moving, cold, dense air moves, fast-moving, cold, dense air moves into an area of warm air. It rapidly forces the warm air to rise up. Rising air condenses into clouds to produce short-lived but strong thunderstorms. So, the cold front, this is the symbol that you'll see on the map for a cold front. Go ahead and draw this symbol on your wicks. When a cold front comes through an area, it will push warm water up very quickly, and when it does that, if there's any humidity in that warm air, it will condense very quickly and it can cause some of your more violent thunderstorms. The way to tell which direction these travel is to see what direction the shape moves. For instance, these triangles are all pointing to the right, so this front is moving to the right. Whereas these are all moving to the, up and to the left, northeast, I would say. So that means the front is traveling northeast. So here is some information. You have this in your weather bag, but we will go over it. So you have the cold air on the back side, you have the warm air on the front side. The cold air is moving into an area of warm air. The warm air rises, can create a lot of clouds, can create thunderstorms. It brings cooler temperature, and if it's high pressure, it'll probably be clear skies. Then we have a warm front. A warm front is slow-moving air, moves into an area of cooler air. Warm air is gradually pushed up, forming a thin layer of cloud cover. So this is your cloud cover right here. Rain showers last for 2 to 3 days. It says moderate precipitation. It just means it's kind of light rain. It tends to last a little bit longer. This is typical of a warm front moving into an area of colder air. So again, warm fronts, the circles on the warm front, that's how you tell if it's a warm front, has circles on the side. Whichever direction the circles face is the direction it's traveling. Warm air moves into an area that is of cooler air. The warm air rises slowly, creating clouds. Storms last 2 to 3 days. And then the weather conditions after the front are warmer, typically have some cloud cover. A stationary front is a barrier between your cold and your warm air masses. Neither one is displacing the other. The air moves parallel. So what this means is stationary means you're not moving. So you have a cold front, you have a warm front, and they're basically stuck. What happens a lot of times with this front is that you can get days and days of light rain. And typically the rain will happen where the two fronts meet, so anywhere along this line. And that rain can take place over a period of time. On the back side of the warm front, this side would be warm, and then on the back side of the cold front, this side would be cold. The front has little or no movement. Sometimes they'll kind of wiggle back and forth a little bit, but generally they have no movement. Eventually, the air masses kind of equal each other out and the front dissipates, but for a period of time they just get stuck. The last type of front we need to talk about is the occluded front. The occluded front is a fast-moving cold front, catches up to a slow-moving warm front. Temperatures will fluctuate with the passing of the different fronts, and severe storms are likely. When I say severe storms, this could be your violent thunderstorms. It could also include, in some cases, tornadoes if you're in the right area of the United States for that to happen. So what an occluded front, there's two ways that you'll see it. Sometimes you'll see an occluded front where it makes a T shape, where they come to a point like this one. Other times you'll just see it like the icon in the top right, where you have alternating triangles and circles, but they face the same direction. That means you had two fronts that met up with each other. Whereas with the stationary front, you notice you have a warm front moving one way, a cold front moving the other. The occluded front, all the shapes are on the same side. So they either make a T, or they have they're all on the same side. They're moving in the same direction. Because the colder air moves faster, it will catch up from behind the warm front and meet up with it. When it does that, it changes the temperatures of the air so quickly that that's when you can get your violent thunderstorms, your tornadoes, things like that. So with an occluded front, again, here's our symbol, triangles and circles on the same side. Fast-moving cold front catches up and overtakes a slow-moving warm front. Usually forms around low-pressure systems, can produce severe weather, and then weather conditions after the front, multiple changes in temperature and humidity and wind direction, and that is why you get the severe weather. Alright, so let's take a break from this for just a minute, and I want you to look at a couple of weather forecasts now that we've talked about the types of fronts. And I want you to look at this forecast from this past weekend, or this weekend, and we'll kind of talk about how this relates back to the types of fronts coming through, as well as the type of pressure systems. So check this out.
Morning, I'm meteorologist Casey Curry with your 1-minute weather. We are still watching a few areas of lingering fog out there this morning, so probably mid-morning before we're really done with all of this. We're also still watching a few scattered showers. Nothing real heavy or severe, enough to keep those roads wet. We are going to keep the clouds today, and in fact, we're going to keep the clouds through the entire weekend as well. As you're planning the rest of your Friday, it's going to be mild temperature-wise. We'll still get up into the mid-70s before we're through today, but we're going to keep kind of this drizzly, damp, cloudy day going all the way through the afternoon hours. As far as rain chances, they'll go down a little bit this afternoon, but we'll still keep a slight chance going into Saturday as well. You'll also probably start with a little bit of fog on Saturday morning. Then things get a little quieter for us as we get a little batch of cool air that settles in on Sunday. Still mostly cloudy skies though. Early next week, some peaks of sunshine, but temperatures staying a bit below average as we head from Sunday into the early part of next week. Have a great Friday.
Okay, so this is the weather from this last weekend that Casey Curry was just talking about, and I want to point out a couple of things. So if you look, there's definitely a change in temperature that takes place between Saturday and Sunday. We started out with areas that were warmer and then had a cold front come through, and that caused Sunday and then the rest of the week to cool off for the overall temperature to be colder. So I want to show you the actual weather map so we can compare this weather forecast to what's actually happening with the weather fronts. So this is the actual weather map from AccuWeather.com for Saturday, December 6th, so this Saturday for this weekend. And we just talked about how on Saturday there's a cold front that's going to come through, and then on Sunday the temperatures get colder. So if you look, here's the cold front. Behind it is an area of cooler weather. In front of it is an area of warmer weather. Because the arrows, the triangles, are pointing southeast, the front is moving southeast. And because of that, it's going to travel through Houston. Now the temperatures don't change until the front gets here. So you notice this is for Saturday at 4 a.m. That means sometime on Saturday, this front will travel through. When we get to Sunday, if I scroll down, by Sunday this front should already have passed through, and that is why our forecasted temperatures for Sunday are lower. Excuse me, this is afternoon Saturday. This is Sunday. The front has already passed through, which means the forecasted temperatures for Sunday are lower than the forecasted temperatures for Saturday, because the front actually will come through on Saturday and it'll be out in the Gulf by Sunday. Alright, so the last thing I want to show you is what we call weather math. It's kind of an oversimplified but somewhat easy way of remembering what types of pressure systems and weather fronts will create varying types of weather. So here's how this works, and I want you to write this down on the back of your paper. If you have a high pressure system plus a warm front, you will get warmer, drier weather. If you have a low pressure system plus a warm front, you will get warmer, more humid weather with possible light rain. If you have a high pressure system with a cold front, you have colder, drier weather, so it's cold outside, it's dry, it's clear. And then if you have a low pressure system with a cold front or even an occluded front, then you get colder, more humid weather, possible thunderstorms. So high pressure plus warm, warm and dry weather, low pressure plus warm, warm, humid weather, high pressure plus cold, cold and dry weather, low pressure plus cold, cold, humid weather. Again, this is very oversimplified. I know there are other factors, but this kind of breaks it down to the very simple patterns that you might find, and then you can take other factors into consideration. So, thank you for watching, and I hope you have a greater understanding of weather fronts and what's happening in our local weather this week, and we will see you in class. Bye, Bengals.